Hello everyone, my name is Anis Sabina and I'm here as the speaker of Group 1 and today I'm going to present about a bibliometric analysis of nature's impact flare gas influence on the environment research using VOSviewer. There are several contents that we're going to discuss today. The first one there is an abstract, the second one there is an introduction, the third one there is an objectives, the fourth one there is an experimental design, the fifth one there is a results and discussion, and the last one there is a concluding remarks. The first one there is an abstract. Burning plays an important role in using flares or gas flares illegally and not being where they should be can cause big problems. Burning that occurs in the environment has a broad impact on many things, so a solution is needed to overcome this problem. Bibliometric analysis is used to investigate the impact of using flares or gas flares on the environment using VOSviewer software. Data was extracted from the Scopus database with the keyword environmental impact of smoke and showed that there were 1,865 publications over 9 years from 2015 to 2023. This shows that interest in research into the impact of excessive and unofficial use of gas flaring on the environment is still low. This article provides an overview of burning research trends that occur in the environment. It covers the bad opportunities that will occur and predicts solutions that can be taken to prevent these bad opportunities in the relevant future. The second one, there is an introduction. Flaring is the process of natural gas being burned in a controlled manner during all extraction to reduce sudden ignition. Natural gas is always collected as stored as best as possible. The flaring of large quantities of natural gas causes economic damage. The compounds contained in the combustion are carbon dioxide, sulfur methane, nitrogen oxide, organic compounds, and black carbon. One method used for flare waste is to utilize the organic Rankine cycle. Rather than dumping waste heat into the environment, waste heat can be obtained by the evaporator method. In addition, it is necessary to reduce the flaring volume by improving the processing condition to implement energy recovery and production methods. There is a slight difference between the definitions of flaring in some references. The World Bank defines flares as the release of associated gas from upstream oil and gas facilities and LNG liquefaction plants, while the Canadian Energy Centre defines as incineration of petroleum waste, hazard emission prevention systems, which are still in pilot or active mode. There are two common ways for flare gas recovery. The first way, which requires less processing, involves flare gas injection into oil and gas fields, transferring the gas through pipelines, underground gas storage, and chance oil recovery and use as petrochemical complex feed gas. The second way is to use different flare gas process strategies covering a wide range of methods, including flare modification and upgrading by liquefied natural gas and gas-to-liquid technology, electricity generation by power plants, steam cycle and combined cycle, and gas compression. The main challenge in zero flaring is to choose one of the flare gas recovery technologies among several known technologies. There are two approaches to implement an FGR system. The first, which requires less extensive processing, is to transfer NG or natural gas through pipelines or piped natural gas used as feedstock for petrochemical plants, enhance oil recovery, and underground gas storage. The second is to operate multiple FGR systems that include different process strategies consisting of gas flares upgrade and modification with compressed natural gas, liquefied natural gas, gas to liquid, gas to hydrate, power plant, gas power plant, and combined power plant, and, and conversion of carbon dioxide and methane flare gases. There is currently no research on the impact of burning of flares of flare gas on the environment, as evidenced by data sourced from the Scopus database and bibliometric analysis. This research used bibliometric analysis. Bibliometric analysis is a scientific review methodology carried out with the help of computers and aims to identify core research authors and their relationship, covering all publication related to a particular topic or field. Bibliometric are often used to measure the influence or impact of research articles. This bibliometric method estimates the amount of influence or impact of a selected research article on future research. The third one, there is an objective. First, research impact of their gas for environment. The second one, processing using Excel and VOSviewers. And the third one, map of the relation between impact of flare gas and basic flare gas recovery technology to perform zero flaring. Next one, there is an experimental design. First of all, we analyze about a flare from the Scopus, and then we use Excel, and then the VOSviewer online. We get the data from the VOSviewer online. The fourth one, there is a result and discussion. The first one, characteristics of the document and year of publication. From 2015 and 2023, 1,865 journals have been collected regarding on the impact of the use of gas flares on the environment. Year 2022 has the most publication with 265 journals. A total of 1,865 journals on the environmental impact of flare gas use have been published in the last 9 years with 12 different document types. Of the 1,865 publications, 1,353 articles were the most published articles, followed by reviews 283 and conference papers 109, conference review 4, short surveys 3, data papers 1, and retracted 1 were only published occasionally. Figure 1 shows the number of publications on the impacts of flare gas use on the environment from year to year. In 2015 to 2023, the number of publications was large, and the highest number of publications in 2022 amounted to 265, and in 2021 amounted to 253. This shows that research interest in the impact of flare gas use on the environment continues to increase in the span of 9 years, so that research opportunities for publications on the impact of flare gas use on the environment are still wide open. The second one is publication distribution of the impact of using flare gas on the environment research top 10 countries. Out of the 10 countries, United States has the most publication with 162 journals, followed by China with 124 journals. The 10 most influential headline sources were identified in the last 9 years from 2015 to 2023. This was done to get an overview of the title source contributing the environmental impact of flare gas. The next one, There is a publication distribution of the impact of using flare gas on the environment research, humans by top 10 subject area. Based on the data, medicine is the most publication subject area with 809 journals, followed by environmental science with 793 journals. The next one, there is a co-authorship map fusion of the impacts of using flare gas on the environment. The color and the connecting lines indicate its relation between writers. Next one, there is a source title most influential of the impact of using flare gas on the environment. Based on the data, International Journal of Environmental Research and Public Health is the most distributed publication with 1,070 1,017 journals, followed by Science of the Total Environment with 77 journals. On the one of the 1,865 publications on the environmental impact of flare gas use over the past 9 years, 160 institutions from 114 countries and 25 undefined countries contributed, represent the top 30 institutions and contributed to the total publications compiled from the Scopus database. In the last 9 years, the Harvard Chan School of Public Health and the University of California from America were ranked as the first and second most productive institution with the highest number of publications, namely 36 publications and 33 publications, followed by the University of Tasmania from Australia and the United States Environmental Protection Agency from America with both 32 publications. The next one, there is a publication distribution of the impact of using flare gas on the environment research top 10 keyword. Based on the data, human is the most distributed with 1,057 journals publications, followed by humans with 898 journals. Term occurrence analysis was used to provide an overview research trends over the past 9 years, analyzed using VOSviewer software. A list of keywords in publication was used to show specific research trends. Figure 2 shows the term occurrence network. The node side of a term illustrates the number of occurrence of that term in publications. The result is that there are 160 items with 3 clusters, 11,812 links, and a total link strength of 21,472 terms such as human, smoke, air pollution, environmental exposure, and article are the most frequently occurring terms and indicate that there is a strong link between the terms. The next one, there is a map version of the impact of using flare gas on the environment research domains from keyword environmental impact of smoke by using VOSviewer. Next one, there is a map version of the impact of using flare gas on the environment research domains from keyword environmental impact of smoke by using in cluster 1 there is in 66 items. Cluster 1 is shown in red. The largest red circle with the term smoke has 159 links, 10,879 total link strength, and 855 occurrence. This term has a close proximity to the term human environmental exposure, which indicates that the three are closely related. According to Soltania, carbon dioxide emission from land burning are claimed to have high global warming potential and contribute to the greenhouse effect and climate change. In 2021, it is estimated that gas flaring emitted about 371 million to 5 million metric tons of gas, which average about 1.2% of global emissions from energy source. Second one, there is in cluster 2, there are 58 items. Cluster 2 is marked in green. The largest green circle is the term human, which has 159 links, and 17,812 total link strength, and 1,057 occupants. The term human is close to the term smoke, article, and environmental exposure, indicating that the four are closely related. This means that the combustion of this gas is directly related to human, where the impact is directly felt by humans. Next one, in cluster 3, there are 36 items. Cluster 3 is shown in blue. The largest blue circle with the term environmental exposure has 159 links, 12,789 total link strength, and 673 occurrence. This term is related to the terms article, human, and smoke. According to Colombo flaring in some places can have harmful effects on human health and ecosystems around the flaring site. Natural gas fires cause varying degrees of pollution such as atmosphere, as well as soil conditions in the vicinity of the fire. Local farmers have complained of sudden growth and productivity of crops in the vicinity of gas flares, as well as scarcity of animals in the vicinity of gas flares. Released toxic pollutants such as sulfur dioxide can cause acid rain that eats away at villages' rooftops, shielding them from rain and acidify nearby lakes and rivers. In addition, the noise, odor, and smoke generated from the flaring activities may disturb the local residents and their comfort in doing outdoor activities. The last one, there is a conclusion or concluding remarks. Based on bibliometric analysis of the impact of flare gas use on the environment over 9 years, public impact of flare gas use on the environment show progress. International Journal of Environmental Research and Public Health is the most sourced title of the top 10 source titles. The United States is the most productive country in publishing the impact of flare gas use on the environment. Harvard T.H. Chan School of Public Health and the University of California have been the most productive institution in the last 9 years. The VOSviewer analysis reveals a close relationship between one network and another. This suggests that smoke, people, and exposure environmental is an interesting topic and has a great opportunity to be published. That's all from me. And from my group, thank you for listening.